Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, background for this problem. We have an electron in a magnetic field, and we are told that it travels in a circular path in this magnetic field. And what we want to find is the radius of the circular path. Things we are given, we know the kinetic energy, abbreviated as Ke for kinetic energy. We are given the magnetic field, and we are told that we're dealing with an electron. E. So that's everything we're given. So we want to find the radius. We need an equation that relates these factors to the radius. And a good equation to start is r is equal to mass times velocity divided by charge times magnetic field. Okay. Now, we're given kinetic energy, and we want mass times velocity. So those can be related, but we need to find out how. We know that kinetic energy is equal to 1/2 mass times the velocity squared. Ke equals 1/2 mass times the velocity squared. So how in the world do we get this to look like this? Well, we are given the kinetic energy, so we have this side of the equation. We are told that we're dealing with an electron. So we can get the mass. We know the mass of an electron is a very small number. Mass of an electron is equal to 9.1, or 1 if you want an extra significant figure, but we only need 2 in this case. This is times 10 to the minus 31. Very small number. This is mass, this is in kilograms, to the minus 31 power. Which makes sense, because electrons are very small. We want it in kilograms because that's the SI unit for mass. And when you're dealing with bigger units, such as units for Tesla or Coulomb for charge, we want to keep everything in SI units. Otherwise, your proportions will be off. So we have this mass now. We can solve for V, which we'll need for this equation, as we can see. Now this M, this is the same M. So we'll use this M twice. So now we can solve for V. We know what the kinetic energy is, so to solve for V, all we have to do is divide both sides by M, multiply both sides by 2. That gives us, don't forget about that squared now. We have V squared. Now that we've solved for it on this side, we've divided by the mass. So we have Ke, the kinetic energy, divided by the mass. We have to multiply both sides by 2. That gives us a 2 up here. And now we need to take the square root to get rid of that V squared, because we only want V here. So V equals the square root of 2 Ke divided by the mass. And now we have V. Okay, now the only thing we're missing is this charge, but once again we know we're dealing with an electron, so we know the charge of the electron. It's often just abbreviated as E. You may have actually seen this equation with Q replaced by E before. The E typically stands for, in the world of physics, the charge of an electron, which we know is 1.6 times 10 to the minus 19th, also a very small number. To the 19th, and this is in coulombs, once again keeping everything in SI units. Okay, so now we have everything we need. You can plug in B, you can plug in this V that you solved for. This goes up here. You have the charge here, Q, that's E, given the magnetic field, and the mass, once again, is the mass of the electron. And that will give you the radius that this electron travels in. There you have it.